You know, that phone in your pocket, the sneakers on your feet, almost everything you own at some point probably took a long trip across the ocean on a massive container ship. These giant vessels are, quite literally, the backbone of our global economy. But making all that happen, well, that's one of the most complex logistical puzzles on the entire planet. I mean, just look at this. Trying to get thousands and thousands of containers onto one of these floating skyscrapers is an incredible engineering challenge. It is a high-stakes puzzle where you have millions of dollars and, more importantly, human lives on the line every single day. So that's the real question, isn't it? How do you stack thousands of heavy metal boxes onto a single vessel, send it out into the wild open ocean, and be absolutely sure it won't just tip over? Or even worse, snap clean in two under all that stress? Well, the answer lies in a piece of software that most of us have never, ever heard of. But before we get to the solution, we really have to wrap our heads around the problem. We need to understand the immense forces at play here. This is not just about lifting boxes. This is a battle against physics itself, where one tiny miscalculation can lead to absolute disaster. So a ship's officer is constantly juggling these critical questions. Is the ship stable? Is it just going to capsize if it hits a big wave? What about the longitudinal strength? Are the forces on the hulls so great that this thing could literally bend and break apart? Is all the cargo tied down properly? And maybe most importantly, have we made sure to keep all the hazardous materials far away from each other? Getting any one of these wrong, that's just not an option. So how on earth do crews manage all of this insane complexity? Well, they have a secret weapon. They rely on a digital co-pilot, a piece of software that's basically the unseen brain of the whole operation, and its name is MACS3. So what is it, really? At its heart, MACS3 is a super intelligent loading computer. It takes in every possible variable you can imagine: the ship's specific design, the exact weight of thousands of individual containers, even the way water is sloshing around inside the ballast tanks, and it crunches all those numbers to guarantee a safe trip. And make no mistake, this isn't some niche little program. It is the undisputed king of the industry. MACS3's holds a mind-boggling 65% of the market share. So think about it like this. If you see 3 container ships sailing on the horizon, the odds are pretty good that 2 of them are depending on this exact software to stay afloat. Okay, so how does it actually work? Let's pop the hood and take a peek inside the MACS3's brain. We're going to see how it helps a ship's officer answer those huge life-or-death questions we were just talking about. So what you're looking at here might just seem like a couple of graphs, but it is so much more than that. This is the software making invisible forces visible. These lines show what are called bending moments and shear forces. In plain English, that's the constant, powerful stress trying to bend the ship or just snap it in half. MACS3 calculates all of this in real time, making sure those forces never, ever cross that red line into the danger zone. All right, next up is what feels like the world's most high-stakes game of Tetris. This module here, called Belko, gives the officers a complete bird's-eye view of every single container on the ship. They can load them, unload them, shift them around with just a click of a mouse, and the system instantly recalculates everything to make sure the ship is still safe. It's how they fit all those thousands of puzzle pieces together perfectly. And what about the really sketchy stuff? Well, that's where the dangerous goods module comes in, and this thing is absolutely crucial. An officer can click on any container and immediately see what's inside. The software acts like a digital watchdog, automatically flagging any problems. For example, it makes sure that a container full of flammable liquids isn't sitting right next to one with powerful oxidizers. That's a combination you really don't want. Okay, so theory is one thing, but let's see how this all works in a real-world scenario. We're going to hop aboard and follow an officer on a voyage to see exactly how they use MACS3 to do their job, step by step. So, meet our ship, the Santa Fiorenza. She's just pulled out of the port of Chiwon, and she is now steaming ahead on her way to Ningbo, China. Now, the ship is loaded and on its way, but for the officer, the job is far from over. They've got to get the ship ready for its arrival at the next port of call. So, while they're out at sea, the officer has a pretty standard checklist to run through in MACS3. Number 1, they have to account for all the fuel and water the ship has used on the trip. Number 2, they need to correct any little tilt or list the ship might have developed. And finally, they have to save all this new data as the official arrival condition for Ningbo. Let's see how it's done. First things first, consumption. You see, a ship is kind of a living thing. It's constantly getting lighter as it burns through fuel and uses up fresh water. So here, the officer is punching in that the ship has burned 70 tons of fuel and used 31.5 tons of water. Every single change in weight, no matter how small it seems, affects the ship's overall balance. And boom, you can see the result immediately. Because that fuel and water came out of tanks that were on the port side, the ship is now just a little bit off balance. The status bar is showing a list of 0.6 degrees. Now, that's a really small tilt, but it absolutely has to be corrected before they get into port to make sure the cargo operations are safe and efficient.
So how do they fix it? Well, they don't guess. They use another tool in MACS3 called the Ballast Sequence Planner. The officer uses it to calculate the exact amount of seawater they need to pump from one giant ballast tank to another. This move perfectly counteracts the weight imbalance and brings the entire vessel perfectly upright, all without ever having to touch the cargo. Pretty slick.
But here's where it gets even cooler. All of that work the officer just did on the ship's bridge, it's not happening in a vacuum. It's actually part of a constant digital conversation that connects that one single vessel to the entire global supply chain. This slide basically shows the whole dance. You see, the ship's officer creates that arrival condition file we just watched them make. That file then gets zapped over to a planner sitting in an office on shore. The planner uses that data to figure out the next loading strategy, and then that plan gets sent to the port terminal so the giant cranes know exactly what to do the second that ship docks. It's this beautiful, seamless flow of information. Let's just break that down one more time. A day or two before the ship even gets there, it sends its data file. The planner on shore then gets to work designing the new load of cargo and using MACS3 to double-check that the new plan is safe. That plan then goes to the terminals so they're ready to go. Then, after all the cranes do their work, the ship leaves with a brand new, fully calculated departure condition, and the whole cycle just starts all over again for the next port.
This digital handshake is what makes modern shipping so incredibly efficient. It's just like the source material says, it's a seamless, time-saving integration of all the critical data. It's the reason these massive ports can load and unload ships with such breathtaking speed.
And you might be thinking, okay, that's cool for the shipping industry, but why does it matter to me? Well, because every single one of those boxes represents a tiny piece of this giant global puzzle. Your morning coffee, the parts for your car, the clothes you're wearing right now. Their journey across the ocean was almost certainly planned, checked, and secured by this very same software.
So, when you boil it all down, the crucial point is this. MACS3 is so much more than just a loading calculator. It is the silent guardian, the digital nervous system that makes sure the incredibly complex and sometimes dangerous world of global shipping just works safely and efficiently, day in and day out.
It really makes you wonder, doesn't it? What other invisible software systems are out there, just quietly humming away in the background, managing all the complex systems that we all depend on every single day without even realizing it?